let's talk about permutations and combinations and understand that there is a difference between the two. So a permutation is when the order matters, meaning if I took the letters O, P, S, and T, and I arranged the word stop or I arranged the word pots, those are two different words, completely different, but they have the same letters. So that's a permutation because the order matters in which I arrange those letters. That's important. Then let's talk about a combination. A combination is something like a ham and cheese sandwich or a cheese and ham sandwich. Of course, no one really says a cheese and ham sandwich, but it's the same sandwich. So it doesn't matter if you say ham and cheese or if you say cheese and ham. So in that case, the order does not matter in which you place those things. So that's a combination. It does not matter. Permutation, again, that's when the order matters. Which is kind of funny to think about if you think about your locker combination. Your locker combination, you cannot put those numbers in any order. They actually are a permutation because the order matters. So let's talk about the number of permutations possible for the letters O, P, S, and T. So if we were going to put our first letter first, and so we're going to pick any one of those four letters, we have four options available. We could choose O, we could choose P, we could choose S, and we could choose T. All right? If once we picked one of those letters, right? Let's say we picked P. All right, take that out. Now, I have three choices available for my second letter. So, because I have O, S, and T available, that means I have three choices available. Now, let's say I picked the O. It's gone. All right, I'm going to do a third letter. I can choose between S and I can choose between T. How many letters is that? You should say there's two letters available, so I can do that. And I'm going to take out the S now. Now, how many letter choices are available? You should say one. So when I want to know how many permutations are available for the letters P, O, P, S, and T, I would say it's 4 times 3 times 2 times 1, which is 24. Meaning there's 24 permutations or orders in which we can arrange the letters, where the orders matter, in the letters O, P, S, and T. Let's try that permutation thing again and you actually do it. Now you see the word water there. What I say is there are 5 letters, W, A, T, E, and R. What I want to know is how many permutations are possible. We're going to use the counting principle, okay? That's what this is called when we multiply them together. It's the counting principle. So if I were to do so, I would say for the first choice, how many letters in total are there? There's 5 available. Okay, multiplied by, I picked one, so I picked the E. Now, I'm going to say there are how many letter choices available for my second letter. What I mean by that is my first letter, I could pick any one of the 5. The second letter, I can pick any one of the 4 remaining. So there's 4. Let's say I picked the T. Now, let's say for my third letter, how many are available? There are 3, and I picked the R. For my fourth letter, I have 2 options available, so I picked the A. And for my last, I only have 1 option available. Now if I multiply those all out, I would say there are how many letters available, or I'm sorry, how many permutations are available. You would say 5 times 4 times 3 times 2 times 1, which is 120, meaning there's 120 permutations that you can make from the letters W, A, T, E, and R. Now let's take that a little bit further. Let's say I had 7 members of a track team, okay? So I have 7 people standing out there. And I'm going to line them up in 4. I'm going to put 4 people for a lineup for a relay race, okay? So I want to know is how many different ways can I line up those 7 people that I have 4 in a row? So, does order matter? You should say yes, order does matter, because if I said Jake, then Tom, then Randy, then Bill, or if I said Bill, then Tom, then Jake, and then Randy, it matters because that's the order in which they get to run. So, for my first choice, for my first member, I have how many of those 7 are available? You should say all 7 are available, right? Okay, now I've taken one of those members away. How many are left? I have 6 left, and that's how many are available for my second choice, for my second person in my lineup. Now I'm going to say I have how many? I've taken away 2, so I'm down to 5 members. So my third person in my relay means I have 5 to choose from. And then my fourth and final person, how many people are left to choose from? You should say 4. Now, I'm not going to multiply 3 and 2 and 1 because I'm not doing 7 people in my lineup. I'm only doing 4. So what I would do is I would multiply 7 times 6 times 5 times 4, and I would get 840. Okay, that's a permutation. And I'm going to show you actually a shorthand of how that should actually look. So let's say we were calling this a permutation, so we're calling it P for permutation. I had 7 members available, and I was choosing 4 of them. Now, that may seem a little weird, but this is what you actually would do. So when you have the 7p4 means there are 7 options. I'm making a permutation, and I can choose 4. That's why I picked starting with 7, and I went 4 spaces. This is the more mathematical way of writing what we just did there. So we'd say the P, which is our permutations, we'd say N, P, and then R, where N is the number of objects available to be chosen. There's a total of, in our last example, 7, and that's for our N. We're making a permutation, and R is the number that I'm actually going to choose. So let's just try this example right here where I have 9 books and I'm going to display 5. Obviously the order matters because I can't say with the books that reading from left to right that they are the same thing, because the order does matter. So I would say 9p5, meaning 9 books, making a permutation, I'm choosing 5. So to do that, I would say how many did I start with, and this is always this number, it's 9. Okay, then I would say times 8, times 7, times 6, times 5. Now, is that 5 choices? Meaning 5 and then I stop. Okay, that doesn't mean 9 times 5, it means 9 times 8 times 7 times 6 times 5, because I chose 5 after the number I started with. I multiply that all together, I would get 15,120. Now let's move on to combinations. This is the exact same looking thing as for a permutation, except I changed from a P to a C, meaning I'm making a combination. So N is still the number of objects chosen and R is at that one time. So when I do it, this is a little more complicated, I'm going to tell you right now. But when I do that, I say that I know that it's a combination and not a permutation. The difference is that this time, let's actually pick a few numbers. Well, before I get to that, here's what a combination, to do the formula, you're going to have to actually do. And I want you to remember this. Now, you're probably going to want to write it down. But if you had NCR, to solve that, you would actually do a permutation, like that, divided by the possible permutations. I know you're going to say, huh? I don't understand what you mean by the possible. But I'll explain that in 1 second. So this is actually what this means. Okay? I'll show you on the next slide. So let's say I have this combination where I am doing sandwich fillings, and I have 5 choices of fillings, and how many ways can I choose 3 of the 5 fillings? How many different sandwiches could I make by choosing 3 of the 5 fillings? So that's a combination, because if I said lettuce, pickles, and tomatoes, or pickles, lettuce, and tomatoes, it doesn't make a difference. Okay, so if I had 5C3, what that would look like then would be 5P3, so the permutation, divided by 3P3. Okay, and in numbers, what that would look like is, come down here, let's do this right here. 5P3. How many possible options are there? There's 5 sandwich fillings, so I'd say they're starting with 5, and I'm doing a total of 3. So 5, then I do the 4 times 3. Remember this. This is my starting number, and this is the number of places I will move to the right with multiplying. I would divide it by, in the bottom row, I'd say I start with 3, and I'm still going to go 3 spaces times 2 times 1. If you actually multiplied that out, you should on the numerator get 5 times 4 is 20 times 3 is 60, and then in our denominator, 3 times 2 is 6 times 1 is 6 still. So if I simplify 60 over 6, I should get 10. So there's 10 combinations because the order does not matter. And I know you're going to say that one was really confusing, so let's just try that again. Okay, so I did 8C2, so I'm making a combination. So again, if I were to translate that out, I would actually say 8P2 over, and then this time it would be 2P2. Meaning, let's bring this numerator down here. What's my starting number? It's 8. How many spaces to the right am I going? 2, so it's 8 times 7. Now for this denominator, I'm going to just go ahead and pretend that's my line. Now I start with 2 as my starting number, and I'm going to go still 2 spaces like that, right? Now let's actually multiply this out, and let's say 8 times 7 is 56. 2 times 1 is 2. I simplify, that gives me 28. So there's 28 combinations when I do 8C2.